Good day, greetings. This is Dr. Rao. Today I am going to teach introduction of basics of electrical components, electric circuits, power and energy, and series circuits. Being as an electrical engineer, fundamentals should be strong. What are the fundamentals? This can be useful for your competitive examinations, for students, for final examination, department tests. All these things is very, very important. Before going for any interview, also 1 hour before or 1 week before entrance or examinations, also you can prepare easily. So everything we know, but starting trouble. For example, we know Ohm's law. How to start? Oh, Ohm's law. Okay, how to start? Like that, we will thinking. If you giving the potential difference between 2 points, like that, anybody can inject means the continuous flow will go. Like that, starting trouble, how to remember all these things. I will going to explain all these things. First of all, you have to explain the voltage. Voltage is equal to every source of voltage is established by simply creating a separation of positive and negative charges. This is positive charge, this is negative charge. This is called separation. This is called the separation. So, the energy source of voltage is established by simply creating a separation of positive and negative charges. This is the fundamental from the physics. 1 coulomb of charge is equal to 6.242 into 10 to the power of 18 electrons. If a total of 1 joule of energy is used to move negative charge of 1 coulomb, means 1 joule of negative charge. This is negative charge with a 1 coulomb. There is a difference of 1 voltage between the 2 points. What are the between the 2 points? Between the 2 points, positive charge and negative charge. So V is equal to W by Q, where V is equal to volts, W is equal to joules, and Q is equal to coulombs. These are the voltage, regarding voltage. Through algebraic manipulations, we can define an equation to determine the energy required to move charge through the at difference in voltage. W is equal to QV. If you want Q, charge, W by V. So voltage is equal to finally joules per coulomb. You have to remember this. Units for this is volts. A small problem. First one. This is for your reference. Find the voltage. So he is asking voltage how much? Find the voltage between 2 points. This is called 2 points. Point 1, point 2. This is 1 point. This is second point. 60 joules of energy required to move a charge of 20 coulombs between the 2 points. So this is 20 coulombs. So what is asking voltage? What is the formula for voltage? Above I mentioned voltage is equal to W by Q is equal to 60 joules by 20 coulombs is equal to 3 volts or 3 joules per coulomb. Similarly, if you want to calculate energy, the same conversation you can use. This is the fundamental. Now we are going for this is called current. The applied voltage is the starting mechanism. The current is a reaction to the applied voltage. See, very good definition, easily you can understand. The applied voltage, this is called the applied voltage, is a mechanism. The current is a reaction. To the applied voltage. Like that we have to mention. If 6.242 into 10 to the power of 18 electrons pass through the imaginary plane below. Figure not shown because this is another thing. So this is called the current. So current is equal to, once again I will explain. Current is represented by letter I is equal to the applied voltage. So voltage is applied here. The mechanism. The current is the reaction. I is the reaction. Like that we have to remember. Okay. Using the coulombs unit of charge, the current in amperes can be determined using following equation because already we follow from the physics. So current is equal to coulombs by time. So many interviews, this only they will ask what is current. Means it is the ratio of charge to the time. So where T is equal to time in seconds, Q is equal to charge in coulombs, and I is equal to, already you know I is equal to amperes. These are the fundamentals of current. So finally, voltage is equal to joules per coulomb. Current I is equal to coulombs per second. So the product of voltage into current is equal to power. P is equal to VI. That is equal to joules by coulomb into coulomb per second is equal to joules per second is equal to watts. The unit of power is watts. I will explain once again the power. The applied voltage in an electrical or electronic system is the pressure to set the system in motion, and the current is a reaction to that pressure. See, once again I am repeating, the applied voltage in electric circuit or system is a pressure. They are applying the pressure. Electrical voltage means pressure. In motion, motion means this is the symbol, rotation or direction, motion. And the current is reaction. This is called current. Reaction to that pressure. Always we are thinking about this entire electrical engineering. These two will be same like that only it is. For example, the charge flowing through the imaginary surface. The charge flowing through the imaginary surface of charge is equal to Q is equal to 0.16 coulombs for every 64 milliseconds. So what we have to calculate now? Two unknowns given. So the combination of these two formula is time with charge. So you will get the I is equal to 0.16 divided by 64 milli means 10 to the power of minus 3 is equal to 2.5 amperes. Like that we have to calculate for every movement. This is the fundamental voltage sources. An electromotive force is a force that establishes a flow of charge in a system due to the application of difference in potential. Voltage source means put to the motion of electrons in the system is called voltage source. So symbol of DC voltage source is like this. Symbol of DC voltage source is like this. This is positive, this is negative. This is voltage source. Types of DC voltage sources. First one, batteries, chemical action or solar energy. Second one is generators. Third one is power supplies like rectification, conversion process to like that, like some modifications. That is called power supplies. Fourth one is, everybody knows, this is called fuel cells. These are the types of DC sources. First one is batteries. The battery is the most common of the DC sources. By definition, a battery is defined or derived or mentioned from the expression of battery cells. Consists of combination of two or more similar cells. A cell being the fundamental source of electrical energy developed through the conversion of chemical or solar energy. Similarly, generators. Quite different from the battery, both in construction and operation mode. When the shaft of the generator is rotating at the nameplate speed due to the applied torque of some external source of mechanical power, a voltage of rated value appears across the external terminals. Here, batteries means no moving parts inside, static mission. Generator means dynamic mission, rotation mission. Input we are giving mechanical, output you will get the electrical energy. So it is a mission which converts mechanical energy into electrical energy. This is called the generators. Next, supplies. Already I mentioned supplies. The DC regulated power supplies. The DC supply encountered most frequently in the laboratories uses rectification and filtering processes. It means toward obtaining a steady or steady DC. This is called some electronic devices will be used to convert some voltage to DC voltage. So output will require DC. Next, fuel cells. Next one is fuel cells. One of the most exciting developments in recent years has been the steady rising interest in fuel cells as an alternative energy source. Fuel cells are now being used in the small stationary power plants, transportations like buses, and a wide variety of applications where portability is a major factor, such as the space. Millions are now being spent by major automobile manufacturers to build affordable fuel cell vehicles. Previously, DC sources are two only, batteries and generators. After that, power electronics developed, solid state developments, so supplies. After that, renewable energy sources, the latest developments, fuel cells become. These are the types of DC sources. Next, materials, conductors. There are 6 types of materials are there. Conductors, insulators, dielectric materials, semiconducting materials, magnetic materials, and special purpose materials. These are the 6 materials for entire electrical engineering. First one is conductors. Conductors. If it is a one equipment or a system, we are applying the voltage. This side voltage will come either a less or more. Whatever it may be, you will get the voltage output. This is input. I for our reference input. This is output. You will get. So this is called the conductors. You are giving apply voltage. That side also you are coming voltage. Insulator. On equipment or on material, we are applying the voltage. You didn't get any voltage output. No voltage. Whatever may be the voltage, giving input, no voltage output. This is called insulators. Next, semiconductors. This is material. We are applying voltage here. Just see. Input voltage. For low voltage, it will act as a insulator. If the voltage is increases, means for high voltage, say or medium or high voltage, this is HITH. It will act as the name itself semi means partial. So this is the semiconducting materials. Next one is dielectric materials. Dielectric materials. Same, we are applying a voltage to the material. The material itself, it will store. It will store whenever you want, it will discharge. Not immediately. What are the voltage we are giving, it will store. That is called dielectric materials. Next, magnetic materials. This is the system or a component or a material. We are applying the voltage. It will give output as a magnetic energy. So this is called the dynamic. This is called the static. Next one is special purpose materials. For soldering, jointing any two materials. Like that we are using some special purpose, like a lead, like that. Okay. Now you can tell me 6 materials in front of you. Okay, leave special purpose materials. Leave insulators. So in that top conductors I explained, voltage going on, output voltage will come. But electric pressure is applying, but opposition should be there. Always there is no current. Opposition of the pressure. That is called the ratio of V to the opposition. It's called the resistance. So from conductors, the resistance is developed. From dielectric materials, capacitance is developed. From magnetic materials, inductance is developed. For semiconductor materials, that is used for the electronics. Like that classification. This is for capacitances, this is for inductances, and the above is resistance. Like that, the materials, entire electrical engineering materials will be divided into 6 types in interview also. But we should remember in our lifetime how many materials in electrical engineering means 6. Insulators, conductors, semiconducting materials, dielectric materials, magnetic materials, and special purpose materials.